Hello, welcome back. Today we will be completing our notes on function notation. What I want you to do is see if you can fill in this box right here of prior knowledge. So go ahead and pause the video for a second or two and see if you can fill that in. Welcome back. Is this a function? It is indeed a function because none of the x values repeat, which are my inputs. What is the rule for this table? We are multiplying by 2. So how we would write that formally is y equals 2 times x. So what output would you get for an input of 50? Well, if you multiply 50 by 2, you get 100. What output would you get for an input of 35? Well, 35 times 2 is 70. And now careful here, what input would give you an output of 12? Well, if you work backwards, if the output y is 12, what input would have given you that? Well, if you solve the equation we set up, you would get that x equals 6. So there you go. Now, here's the deal. There is a more sophisticated way to write function rules, and it's called function notation. So if you check out the old way, this is what we used to do. We used to write equations y equals 3x plus 4. This means that y is a function of x. In other words, y depends on x. So the ordered pair we write is x comma y. The new way is read f of x equals 3x plus 4. So this is the same equation, but we're just replacing y with f of x. So basically this is a replacement for y. And the ordered pair would be written x comma f of x. What that basically means is we would write, say the ordered pair was 3, 4. We would write it 3 comma f of 3. So it's saying the y value when x is 3. So you'll see a little bit how that works as we keep on going through our notes. So our first function here, we always have to be told what the function rule is. So we're told right here, f of x is 3x plus 4. And we're going to use that for questions 1, 2, 3, and 4. Okay? So it says evaluate f of 2. So what it wants me to do is basically plug in 2 for x. It's an input, and how do I know that? Because it's inside these parentheses here. So f of 2 is equal to, I'm going to take my function rule, and wherever I see x, I'm going to replace it with 2. So if you notice, I just took anywhere I had an x and replaced that with 2. And now I'm just simplifying the right side of the equation. So 3 times 2 is 6, plus 4, and really I'm using order of operations here. 6 plus 4 is 10. So what we would say is y, aka f of 2, is equal to 10. I can also write that as an ordered pair with my x and my y value. So it would be 2 comma 10, the ordered pair. And you can really write the answer in either of these two ways. Some prefer the ordered pair, some prefer the function notation. All right, so let's try another one like it. This time we're going to replace x with 3. So I'm going to write f of 3 equals 3 times, instead of x, I'm going to put 3 plus 4. Simplify the right side. 3 times 3 is 9, plus 4 is going to give me 13. So bring down your f of 3 notation to say that f of 3 equals 13. The ordered pair would be 3 comma 13. So there's your answer. Not too bad. Now, you've got to be careful because you're also sometimes asked to find what the input was, what the x value was for a specific output. So if you look here, 25 is on the outside of the parentheses, so it's an output. So I'm going to take my function goal, f of x, which is 3x plus 4, and I'm going to set that equal to 25, because my function had an output of 25. And now I just need to find x, so I'm going to unravel this equation by undoing the operations. So this is basically just solving an equation. Subtract 4 on both sides, divide by 3, and you'll get x equals 7. You can also write this as an ordered pair. Your input 7 for the output they gave you 25. So you do have to be careful here because it's really easy to just get in the groove and go, oh, 25. So f of 25 equals 3 times 25 plus 4, but that's totally wrong because 25 is not inside the parentheses. It is an output, so it needs to go on the outside of your equation. So try and keep that in mind as you do classwork, homework, all that good stuff. All right, so let's try this again. Look at number 4. Is -8 an input or an output? Well, it's on the outside of the parentheses, so that is an output. So I'm going to set my function 3x plus 4 equals that, and solve. So subtract 4 on both sides. 3x equals -12. Divide both sides by 3, and you'll get x equals -4. As your input, they gave you the output of -8. So you can also write it as an ordered pair. X, comma, y, -4, comma, -8. So there you go. The last two here, we're just going to use a different function. So now we're going to use g of x instead of f of x. And that's another cool thing about function notation is you can name your equations. So they don't all have to be y. You could even name an equation after you. I could make one k for Kavanagh of x and make myself a little equation. So, like I said, you can name the equations with different letters if you're working with multiple equations at the same time. So let's try using g of x. So it wants me to find g of 2. Is 2 an input or an output? Well, it's an input inside the parentheses. So I'm going to input 2. Anywhere I see x, I'm putting 2 in parentheses. You can never have too many parentheses. Simplify using order of ops. So 2 squared is 4, plus 2 times 2 minus 1. Next would be to multiply. 2 times 2 is 4. 4 plus 4 is 8. 8 minus 1 is 7. G of 2 equals 7. And you can write the ordered pair as well, 2, 7. Definitely in your notes be writing both the ordered pair and the function notation. I know I say you can do either or, but I do want you to have that in your notes. Okay, let's try plugging in a different value to g. So this time I'm going to replace x with -2. The parentheses are super important here, particularly when I'm squaring -2. And we've talked about this before, why that is. So again, using order of ops, -2 squared is +4. Bring everything down. 2 times -2 is -4. 4 minus 4 is 0. 0 minus 1 is -1. So g of -2 equals -1. And the ordered pair would be -2, -1. So it's really not bad, it's just a new notation. Really, you're doing the same stuff that you've always been doing, substituting values and simplifying. So go ahead and flip over and we're going to look at another representation of functions. And that is evaluating functions from a graph. So remember, inputs are x values, outputs are y values. So number 1 asks me, what is f of 0? Essentially what that's saying is, when x is 0, what is the y value, or the function value? So I'm going to go over here on my graph to where x equals 0, and I'm going to follow it up to where my function has the x value of 0. And I want to know, well, what's the y value there? Well, if you look at your y-axis, what is the y value there? It's 3. So we would say that f of 0 is 3. And has the ordered pair 0, 3. For f of of 1. What is the y value when x is 1? So I'm going to go over to x equal to 1 on my x-axis, follow that up to my function. Right here, so that's where I have an x value of 1. What is my y value? Well, my y value is also 1. So f of 1 equals 1, and f of ordered pair 1 of 1. f of 2 is asking the question, when x is 2, go this up a bit, when x is 2, what is y? So go over to where x is 2, and follow it this time down, where your function has an x value of 2. And what's the y value? Well, that would be negative. So f of 2 equals negative 1, and has the ordered pair 2, negative 1. f of 3, when I have an x value of 3, what is my y value? So I'm going to go over to 3, follow it down, and for an x value of 3, I have a y value of negative 3. There you go, we've got the point 3, negative 3 on our line. Number 5 looks weird, but it's really just asking you to add two numbers together. Because f of 0 is the y value when x is 0. So what is f of 0? Well, remember, we actually figured that out already. f of 0 is 3, and f of 1 is 1. So essentially, all they're asking you to do is add 3 plus 1. Because f of 0 is 3, f of 1 is 1, and so that is 4. Now, just like when you're evaluating the equation, you can go backwards on the graph as well. Number 6 says, where does f of x equal negative 3? So it wants me to figure out the x when y is negative 3. So we have to go over to our graph where we've got a y value of negative 3. So that would be right here. Where we have a y value of negative 3. So follow that over. And we're looking for the missing piece when y is negative 3, what is x? Well, I can figure that out. Follow it up to your x-axis, and that has an x value of 3. So where does f of x equal negative 3? We would say that happens at x equals positive 3. So not so bad there. You're just working backwards. Okay, I really want you to keep in mind that you can rewatch parts of this if you're having trouble on your U-Dubs. So go ahead and try your 8 U-Dub problems. And I want you to keep in mind, number 6, you're going to have a decimal. And that's okay. Just estimate as close as you can. And then for number 8, there should be 2 x values where y is 0. So you're really looking for 2 x values there. Keep that in mind, and go ahead and try your U-Dub problem.